Description of section. Sisian-Kajaran section begins from the southern foot of Mount Metishhanasar, 3,550 meters. It crosses M2 highway, passes through the left bank mountain slope of the Vorodon River, and crosses the Vorodon River through the upper part of Sham Water Reservoir. Then it passes through the nearby areas of Varatin, Vorodon, Darbas, lower communities, crosses the Berkshire Ridge with spot heights of 3,000 meters and higher, through mountain slope on the left side of the Shenatah tributary, and passes through mountain slope on the right side of Berkshire River Valley in the vicinities of Nor Astrabert, Geri community. Finally, it reaches the right side mountain slope of Kapan-Kajaran road section and continues to the entrance of the communities of Kajaran and Lernadzor. 3 interchanges are designed for Sisian-Kajaran section. The first interchange is designed within kilometer 0 plus 0 and kilometer 1 plus 0, with the aim to connect the existing M2 and local roads with the newly designed Sisian-Kajaran road. Road will be furnished with safety barriers. Road signs will be placed to ensure traffic safety. From this preliminary analysis, in many sites, the need of retaining walls is envisaged. The drainage system will be ensured, calculating water flows with culverts of different sizes and drainage chutes. Excavated soil and aggregates shall be reused as much as possible. The site location of topsoil stockpiles and excavated material landfill will be properly designed. Permit and access to those sites should be obtained prior to the commencement of excavation works. Air quality, noise and vibration shall be surveyed during the environmental impact assessment process in order to update the environmental baseline data. The second interchange is designed within kilometer 15 plus 400 and kilometer 16 plus 300, with the aim to connect local roads to Varatin, Vorodon, Sham, Lezen, Datev, Darbas, Getata, Lor, Shenatah with the newly designed route. The Sisian-Kajaran Tranche of North-South Road Corridor lies in a region of complex geology, characterized by extensive quaternary volcano-sedimentary deposits in the northern part and by an orogenic belt constituted by sedimentary, igneous, and metamorphic rocks in the central southern part. Road excavation will encounter a large variety of conditions, ranging from debris deposits, usually in loose state, through partially cemented lacustrine soils up to strong, medium to slightly fractured igneous rocks. Landslide activity along the valley sides is relatively limited and affecting mostly the superficial soil cover. However, a few large paleo-landslide bodies have been also identified that now appear to be in a stable state. Road foundations will usually rest on fair ground. Nevertheless, the use of piles may be required, especially for the abutments and piles of bush structures crossing loose deposits. Main obstacle of Sisian-Kajaran road section is represented by the Berkshire Ridge, of about 3,200 meters height from the sea level. The proposed solution is to cross the ridge with the Berkshire Tunnel. The Berkshire Tunnel is 8,683 meters long. For this reason, safety issues are an important concern. The following prevention measures will be ensured: lighting, fire system, escape way, Access to escapeway at every 500 meters, layby at every 1000 meters, SOS at every 250 meters, smoke extraction, ventilation. In case of fire, the smoke is extracted by ventilation systems at both ends of the tunnel, inside the smoke extraction duct. People will have an escapeway located under the platform every 500 meters and then an escape route to a safety place. In case of fire, the passengers can reach the nearest emergency exit, one every 500 meters, and through the door and the stairway reach the escapeway located under the road platform, which runs all along the tunnel and finishes at both extremities with an exit on the outside. The entire zone, stairway and escapeway is kept under pressure in order to avoid the entrance of the smoke and allow a safe exit to the passengers. The geological conditions along the base tunnel, with length exceeding 8 kilometers and a maximum overburden of 1,160 meters, are foreseen extremely variable due to the complex geological structure of the Berkshire mountain range. Therefore, a high level of geological risk should be expected. Up to Berkshire Tunnel and after that, the area is characterized by a challenging area, especially in terms of vertical slopes. Due to complicated relief features of the area, a large number of bridges and tunnels are designed. There are numerous archaeological and historical cultural values in the area: ancient settlements, castles, churches, tombs, and so on. Number of archaeological sites is likely to increase after a more detailed study and research of the area. The road is located in an area with high recreation and tourism activity, and it is obvious that the implementation of the project may have a direct impact on it. In the cut sections, the maximum height of the cut is 10 meters. The slope of the cut is related to the type of soil. Every 10 meters, 2-meter bench is located to assure the stability of the cut and to accommodate the rolling material coming from the top. There are agricultural and non-agricultural, special use, forest and water lands in the affected communities of the Sunik province. Most of the affected lands are community-owned. The studied corridor project does not have any negative impact on the quality of the soils for the surrounding areas. The third interchange is designed to connect the newly designed road section to the existing empty road between kilometers 55 plus 500 and kilometers 59 plus 0, through which the movement of vehicles will be implemented with Kapan and adjacent communities. This intersection will give an opportunity to move with separate ramps, from Kapan to Sisian, from Sisian to Kapan, from Kapan to Kajaran, and from Kajaran to Kapan. Bridges. Main structures of the project consist of bridges aimed to cross valley, rivers, or other kinds of obstacles. The total number of bridges is 27, and they can be grouped into the following main typologies: steel concrete bridges, maximum span length up to 72 meters; precast concrete bridges, maximum span up to 28 meters. The Sisian-Kajaran area is totally mountainous, and it is more difficult and challenging to face. Depending on the steepness of the valleys, most of the bridges, 22, are built in steel concrete deck, while the other 5 are made with pressurized precast beams, which are cheaper. In terms of length, the steel bridges are more than 90% of the total length of bridges. Tunnels. For the design of the 9 galleries included in the project, it has been assumed the construction of only a single tube. That means single carriageway with two-way traffic. The construction of the second tube is postponed to the another phase. The total tunnel length is 12,938 meters. Number of galleries less than 1,000 meters is 8. Galleries less than 1,000 meters is 4,255 meters. Minimum and maximum cross-sections of short tunnels are 110 square meters and 128 square meters. Length of Berkshire Tunnel is 8,683 meters. Minimum and maximum cross-sections of Berkshire Tunnel are 133 and 141 square meters. Cross-section of Bailey of Berkshire Tunnel is envisaged to be about 195 square meters. In Tranche 4, the geometric sections will be the following. The left section is for galleries less than 1,000 meters and the right section for Berkshire Tunnel only. For each kind of geometry, tunnels less or more than 1,000 meters and Berkshire Tunnel, several types of cross-sections have been envisaged. Precisely, some of them, A-type, to be applied when the core face is stable, very good rock. Some of them, B-type, to be applied when the core face is stable in short term, medium good rock. Some of them, C-type, to be applied when the core face is unstable, bad rock or terrain. Each tunnel is designed separately. The input data were reported on the profile, and accordingly, the different sections are applied, giving a change at the beginning and a change at the ending of the tunnel. A numeric evaluation of the structural parts, number of micropiles, thickness of the lining, typology of the steel ribs, etc. The sections A, B, C to be applied. A percentage of application of the sections when there are more than one in a single part. Of course, there will be also a guideline to help to choose the right section depending on the real condition of the rock, directly observable during the works. Sometimes it was preferred to give different sections of application with a percentage for each of them. This will allow the engineer, during the works, when the face front of the gallery is directly observable, to choose the better one among different types.